we have various renewable energy sources also, but so 1 minute, sir. There is some technical issue. Hello, sir.
Yes, go ahead. Go ahead. Pradeep, continue.
Yes, sir. So like electricity, hydrogen is an energy carrier that has ability to deliver incredible amount of energy. Onboard hydrogen storage in vehicles is an most important factor that should be considered when designing fuel cell vehicles. Sir, if you want to design a vehicle in such a manner that if we want to utilize hydrogen, so that we should think of the vehicle in which we can store the hydrogen, and as well as so some feasible storage for that vehicle. So we need to develop the vehicle as we want to store the hydrogen for the utilization of that hydrogen, sir. So this is all about the introduction what we are going to make the hydrogen fuel cells so that we can utilize in the vehicles. So now let us see what is hydrofuel cell. A fuel cell can be defined as an electrochemical cell that generates electrical energy from fuel via an electrochemical reactions. So now if we see a fuel cell, that is a cell which generates the electrochemical reactions. So electrochemical cell which generates the electrical energy from fuel via an electrochemical reaction. When the electrochemical reaction takes place, the electrical energy is developed by the hydrogen fuel cell. So fuel cell required a continuous input of fuel and an oxidizing agent, generally oxygen. So here the hydrogen cell requires some amount of oxygen or more amount of oxygen so that it can oxidize. It acts as an oxidizing agent and it can oxidize with the hydrogen and form the electrical energy, and as well as it forms the byproduct as H2O, sir. So that in environment it cannot cause some harmful effect or nothing hazardous to our environment. So it is all, we can say that by this it is economical friendly and eco-friendly also. So below I have mentioned that chemical reaction 2H2 plus O2 gives to H2O. So when an hydrogen fuel cell reacts with an oxygen, so it forms a byproduct as water. So it is not more hazardous. Not only more, it is nothing at all hazardous to our environment. So side I have given a diagram also, sir. So in that you can see that we can inject the fuel as a hydrogen cell, and the excess is removed out by the another excess fuel, and so these hydrogen go on reacting with oxidizing agent. Those are oxygen molecule, and we get the electric current is generated, and the remaining byproduct we get is water. So now how hydrogen fuel cell works in the car. So let us see how this hydrogen fuel cell work in the car as we implement in the vehicles. In the study, a recent development in hydrogen fuel cell engine is reviewed to structuralize the feasibility of using hydrogen as major fuel in the transportation system. So we can use hydrogen fuel cell in alternative to these petroleum product engines and other electrical engines. So we can get efficient, means more efficient to whatever we are getting in the petrol and diesel engines. So I think I can say that it is no more less than the petroleum and diesel engines. So a fuel cell is an electrochemical device that can produce electricity by allowing chemical gases and oxidants as reactants. As I already said in the how the fuel cell works. So again I have mentioned here, with anodes and electrolytes, the fuel cell splits the cation and anion. So in the manufacturing of fuel cell, we have placed the anodes and cathodes in that. So electrolytes, the exchange of electrolytes takes place, and exchange of ions takes place.
Nanda,
so that yes sir, fine. So now let me go to the benefits of hydrogen fuel cell. No emission of carbon monoxide. means carbon free. We can, by the usage of hydrogen fuel cell, we can develop a carbon free environment, and it is most efficient as compared to the others at low cost. So nowadays petrols and diesels, these are becoming very high prices, so that we can use it in a low cost and produces water as a byproduct after the uses. So now we can see that instead of carbon dioxide, carbon monoxide and other carbon emissions, it is more effective to environment because it produces water as a byproduct. So we can use it for other uses also, and renewable source of energy and pollution free. So it is also a renewable source of energy which doesn't cause any pollution, and we can say that it is a pollution free. So another reduced dependency on other countries. See, nowadays what happened, if we want to import a petrol or diesel from other countries, so we should be dependent on other countries. So I think this can be reduce the dependency of an other country. So next, pollution analysis. Just I have given a pie chart here. Major source of pollution in India in 2022. So thank you, sir, and thank you for giving me such an opportunity to present my presentation. Thank you, sir.
Pradeep,
Okay, sir.
there are two reactions taking place now. One is that hydrogen what you are
Yes, sir. We
giving
hydrogen
input,
fuel
and
cells.
one more
Oxidizing
reaction.
agent.
That reaction you have given, no? So where
Yes, sir.
oxidation takes place and where reduction takes place? What electrode?
Sir, when we at the time of manufacture of hydrogen cell, we have used their electrolytes, sir, anode and cathode, sir. So what we hydrogen fuel cell, what we have taken to manufacture that, sir, and oxidizing agent, the oxygen available in the environment, no, sir. So both
Yes, yes.
that reacts, sir, reacts and forms, sir, electrical, generates the electrical energy, sir.
Okay. So what is my question is hydrogen is going to oxidize or oxygen is going to oxidize?
No, sir. Hydrogen is actually hydrogen is oxidizing agent, sir, which itself goes under reduction and produce the product, sir. Hydrogen is a
And
yes, sir, oxidizing agent, sir. Yeah, it oxidizes, sir.
it is oxidizing agent.
Okay, sir.
Okay.
Hydrogen acts as
And
oxidizing agent,
oxygen?
sir.
Okay, okay. Thank you.
Thank you, Pradeep Rodanawar. Next participant is Renuka Bisna.
Yes, sir.
Are you ready?
Yes, sir. May I audible, sir?
Yes, you are audible. 1 minute. Now you can share your screen.
Yes, sir. Shall I start?
1 minute. First, you share your screen. Now you share your screen. Yes, it is visible now. You can start.
Very good afternoon to all of you.
Renuka, start.
Yes, sir.
You can start your video also.
A very good afternoon to all of you. So firstly, I wish all of you happy National Energy Conservation Day. Myself, Renuka Bisalnai from Tunga School of Basic and Applied Sciences, Jamkandi. So today I am going to deal with the concept, application and challenges of nuclear energy. Nuclear energy is made in power plants by splitting the nuclei of heavy atoms such as the uranium. The splitting of nuclei releases a very large amount of energy when the atoms are arranged properly in a machine called a nuclear reactor. Each splitting nucleus can induce its neighbors to split in turn, creating a controlled chain reaction. Reactors can convert the released nuclear heat into electricity, shop horsepower, building heating, desalinated water, hydrogen, and many other things useful to human civilization. Now, let's see, there are two fundamental nuclear processes considered for energy production. One is fusion, another one is a fusion. First, we see the fission. Fission is the energetic splitting of large atoms such as uranium or plutonium into smaller atoms called a fission products. To split an atom, you have to hit it with a neutron. Several neutrons are also released, which can go on to split other nearby atoms, producing a nuclear chain reaction of sustained energy release. Fusion is the combining of two small atoms such as a hydrogen or helium to produce a heavier atoms and energy. These reactions can release more energy than fission without producing as many radioactive byproducts. Let's see in a diagram, one is fission and another one is a fusion. Next, we see the India's nuclear energy. Nuclear power is the fourth largest source of electricity in India after thermal, hydroelectrical and renewable source of electricity. India has 20 nuclear reactors in operation in 6 nuclear power plants, 4,700 megawatt, while 7 other reactors are under construction and are expected to generate an additional 5,300 megawatt. India has been making advances in the field of thorium-based fuels, working to design and develop prototype of our atomic reactor. Using thorium and low-enriched uranium, a key part of India's three-stage nuclear power program. Now, see the applications of nuclear energy one by one. So first, a clean source of electricity. Combustion of fuels such as coal and natural gas release carbon emission into the air. Nuclear energy is the only source of electricity that does not release any carbon into the atmosphere. Second one is national security. Having a solid civilian nuclear sector supports national security and energy diplomacy. It helps develop strong relationships with other countries by fostering the peaceful use of nuclear technology. Third one is nuclear power plants brings the jobs and prosperity to country. And the fourth one is nuclear technology is used in industries. Fifth one is agriculture uses of nuclear technology. Sixth one is environmental uses of nuclear technology. Seventh one is biological experimentations. Last one is medical diagnosis and treatments. Next, we see the challenges of nuclear energy in future days. First one is public awareness. Commercial nuclear power is sometimes used by the general public as a dangerous or unstable process. This perception is often based on 3 global nuclear accidents. Its false association with nuclear weapons and how it is portrayed on popular television shows and films. Second one is constructing new power plants. Building a nuclear power plant can be discouraging for stakeholders. Conventional reactor designs are considered multi-billion-dollar infrastructure projects. High capital costs, licensing and regulation approvals coupled with long lead times and construction delays have also deterred public interest. Last one is larger operating costs. With the strict maintenance regulations, need for staffing, training, and regular inspection, it is costly to compete in the nuclear energy market. The Department of Energy works to solve this challenge by modernizing plant system. This reduces the operation and maintenance cost of this system. Thank you, sir, for giving this opportunity on the national webinar for Natural Conservation Day. Thank you, sir.
Thank you, Renuka.
Thank you, sir.
Nagappa sir, any questions?
We'll take next presentation, sir. No questions.
Okay, sir. So next participant is Rose Montero, RLS College, Belagavi.
Yes, sir.
1 minute.
Am I audible, sir?
Yes, you are audible. Start now.
Thank you.
Rose Montero.
So is it visible?
No, you share your slides.
Yes, sir. Just a second. So is my screen visible?
No, not yet.
So now is it visible?
No, so there you have a share screen option, green color.
Yes, sir.
Click on that.
So I did it.
Then
Sir, is it
not,
visible now?
no, it is not sharing. One minute.
Yes.
So, yes, it is visible now. Open your
Okay. Okay, sir.
open your slide.
Is it okay, sir?
Yes, it is okay. Start now.
Yes. Thank you, sir. So as we are talking about renewable energy, so as we know, renewable energy is a type of energy which is not replenished easily. And now I would like to start with my topic, that is nuclear power plants. So before moving forward, let us know what is nuclear energy. So nuclear energy is that power which is related to something to nucleus. So the help of nuclear reactions to produce electricity, so that can be termed as nuclear energy. As we can see on the slide, it can be done in various ways, that is nuclear fission, nuclear decay, and nuclear fusion. So nuclear fission is nothing but a larger molecule splits into two molecules of like two nucleus with some emission of neutrons. And fusion is where two nuclei come together to form one large nucleus. So let us move forward. So let us know more about nuclear fission. So it occurs when a neutron slams into a larger atom, forcing to excite and split it into two smaller atoms. So as we can see here, a nucleus is present, and as we know, the nucleons are made up of protons and the electrons. So protons are holding the positive charge and electrons are holding the negative charge, and there is a bond between them. So when the bond is broken by nuclear fission, there is huge amount of energy produced, and that energy can be utilized to produce electricity. So that is nuclear power plant. The application of nuclear fission into nuclear power plants is done in this manner. So next, so let us know what is a nuclear power plant. So a nuclear power plant is thermal power station in which heat is a source of nuclear reaction. And as a typical thermal power stations, here the generation of steam is later connected to the generator, and then it is converted into an electricity. So here is the mechanism of a nuclear power plant, where you can see a reactor, then heat exchanger, steam turbine, and that is connected to an alternator, and also the condenser. So what happens here is nuclear fission mainly takes place in the reactor, and when the nuclear fission takes place, there is energy produced in a large manner, and that is then converted into steam, and the steam turbine rotates, and in turn the shaft of the alternator also starts rotating, and due to which the electricity is generated. And the role of condenser is that the steam which is left over in the steam turbine, that is passed on to the condenser, and the condenser makes that again to get condensed, and it is again derived into water. So as we can see here, there is no wastage of any raw material, that is again useful for the human purpose. Next, nuclear power as renewable form of energy. So as we know, nuclear energy, the energy which is produced by nuclear power is renewable, but the fuel that we use is not renewable. So this can be a negative part, but 96% of the fuel which we are using is recyclable, and nuclear, only the 4% of it is non-recyclable. So it is mostly, it has a positive impact, I feel. And so next, now advantages, the advantages are many. So here we can see it is 91% efficient, high energy production, and also it is used in some biological processes such as making food safe. So we can say the radiations which are there from nuclear reactions, we can use those radiations to kill bacteria in our food. It sounds something weird that we are using some radiations in the food, but it makes our food safer, not the dangerous one. Next, it causes low pollution and it is cheaper over other energy sources. But there are some disadvantages also. Here we can see the storage, the proliferation, then the high startup cost has the disadvantages. So here we can see there were some natural disasters caused by these nuclear, we can say natural disaster caused these nuclear disasters in 1979 and 2011. So there are some challenges which are faced by these nuclear power plants. So public awareness, used fuel, transportation, constructing new power plants, high operation costs, these all are some challenges which we can see. And nuclear power plants in India. So in India, I can say nuclear power plant is really helpful because we can achieve much more things by nuclear power plants. We can see there are 23 nuclear reactors in India and 7 power plants in India. So we can have a main this thing where you can see Mr. Anil Karodkar has the former chairman of the Atomic Energy Commission. He has stated that India can't meet the zero target without nuclear power. So this is very useful. So this is the graph which we can see here. It is increasing, and we can estimate that in 2031 we have the large amount of nuclear energy produced. So this can be helpful. So thank you for giving me this opportunity to present. Thank you very much.
Thank you, Rose. Nagappa sir, any questions?
Yes, I don't have any questions. We can take next one.
Okay, sir. So now I
Thank you,
request. Thank you. So now I request Sachin Rogi
Yes,
from
ma'am.
Bashweshwar Arts and Science College,
Yes,
Bagapur.
ma'am.
Okay, you can start now.
Yes, ma'am. Ma'am, visible? Hello? Hello?
Yes,
Yes,
visible.
it is visible. Go ahead.
Hello, everyone. Good afternoon. Good afternoon to all. I am Sachin, BVS Basweshwar Degree College, Vidyagiri, Bagalkot. First of all, introduction. I represent by hydrogen fuel cell as future fuel. First of all, introduction of hydrogen fuel cell as future fuel. In environment rising, CO2 fuels have directly contributed to the global warming phenomena. In order to control the climate change, there is an urgent need of energy transition from current source of fuel to clean fuel. And also introduction hydrogen. All of you know that hydrogen, the first and very reactive element. Also exothermic reaction with O2. Exothermic reaction means that chemical reaction. It involves release energy in the form of heat or light. Highest energy density by mass. Byproduct is water, can be made from water. Why hydrogen is considered as future fuel? Although abundant on Earth as an element, hydrogen is almost always found as a part of another compound such as water and methane. It must be separated in the pure form H2 for being used to fuel. Pure hydrogen H2 reacts with pure oxygen to form water and reacts energy. The energy release enables hydrogen to act as fuel. Hydrogen can be considered as clean fuel provided produce only water when Usage of hydrogen as fuel. Hydrogen can be used in fuel cell generate for using chemical reaction rather than combustion producing only water and heat and byproduct. It can use cars, house and portable powers and many more applications and also used for space rockets and cars and trains. The problems of using hydrogen fuels in the cause arise from the facts that hydrogen is difficult to store in the either high pressure tank or psychogenic tank. For storage, does allow for long-term scalable power storage, very inefficient 30% plus loss, pumped hydro for large scale. Production of hydrogen. Hydrogen can be produced from diverse domestic resources, including fossil fuels, biomass, and water electrolysis with electricity. Conventional hydrogen production using natural gas includes significant environmental impacts, as with the use of any hydrocarbons, carbon dioxide is emitted. Some projects are underway to decrease cost associated with the hydrogen production. Drawbacks. Although hydrogen has high control content per unit mass at room temperature and atmosphere pressure, it has very low energy content per unit volume compared to liquid fuels or even neutral gas. For this reason, in the usually either compressed of liquid fuels by lowering its temperature to less than 33 Kelvin. High pressure tank be much more than the hydrogen they can hold. For example, in 2014 Toyota Miria, a fuel tank contains only 5.7% hydrogen, the rest of the weight being the tank explosion at the hydrogen filling station have been reported. And finally, conclusion, hydrogen fuel cell as a future fuel. The hydrogen fuel is as a future fuel because high amount of carbon related source harm to nature, but hydrogen will not harm to nature which is eco-friendly for nature, and also high amount of hydrogen can produce India also become an developing country. Save or use renewable source developing country. Thank you for giving opportunity.
Thank you, Sachin Ruby.
Okay, good. We'll go to next presentation, madam.
Okay, sir. The next is Sahana Targar from KRCES College of Education, Bailongal.
Yes, present.
Okay, you can start now.
Okay. Is it visible?
Sahana, wait.
Hello?
Yes, it is visible. You can start.
Okay. Good afternoon, everyone. Myself, Sahana, from KRCS College of Education, Bailongal. So, on the occasion of National Energy Conservation Day, which is conducted on December 14, we have conducted a webinar on the topic Renewable Energy Resources, Opportunities, Challenges. So, I have chosen the solar energy. Before going to understand about the solar energy, let's understand the renewable energy resources. So, renewable energy resources are these are the resources which can be used repeatedly and does not run out because it can be replaced naturally, such as biomass energy, hydropower energy, wind energy, solar energy, geothermal energy. So, these renewable resources are classified into these 5 types. Now, let us begin with the solar energy. Solar energy is any type of energy from the sun. It is radiant light and heat which we get from the sun that is harnessed using a range of technologies such as solar power to produce an electricity. So here from the sun we convert the solar power into an electricity. So mainly the sun's energy is transformed into electricity through photovoltaic models, which means photo means light, voltaic means electricity. So these PV modules absorb the sunlight from the sun and convert those usable energy into an electric current. So here in the slide, you see these are the solar planets which are arranged in a large areas. So here the question comes: why should we use solar energy? Because the sun shines all over the world, making solar electricity visible everywhere, and there is no production of greenhouse gases from the solar energy, so we can use it viably. They are cost effective for remote locations, and the sun provides abundant energy to us, so we can use it at anywhere and any time. So how solar energy works? So picture shows that the sun is producing the heat and light on the solar panels, which is placed above the roof of the house, and these solar panels are connected to a control device which mainly converts into an electricity. So the electricity then passes through the beaker box to the outlets in the building. From this, the electricity is provided to the refrigerator, TV, all the household articles we use. So benefits of solar energy. So impact on environment. Solar energy mainly have negative impact on the environment, reduces your energy bill. So as we can only produce our own energy from the sunlight, it reduces our energy bills. Energy production during the peak hours. So mainly we use the electricity during morning 11 o'clock to evening 4 o'clock. So at that time, the sun will be also, the heat from the sun will be also large. So at that time, we can use it more. Solar energy is applicable everywhere. As the sun is visible all over the world, it can be applicable anywhere. Less electricity lost during long distance transport. So most of the energy is consumed during the long distance transported. So we can adopt it there also. Job creation. So it creates job opportunities for many people. Opportunities of using renewable energy resources. Generating energy that produces no greenhouse gas emission from fossil fuels and reduces some types of air pollution. Mainly these energy resources reduces the air pollution in the environment. Diversifying energy supply and reducing dependence on imported fuels. So as India mainly import the fuels from other countries, so it reduces that also, creating economic development and jobs in manufacturing, installation and more. Less global warming, improved public health, inexhaustible energy, jobs and other economic benefits. So this is the graph showing all the renewable energy resources throughout the past years. Next, these are the challenges of using renewable energy resources. Availability of power. So we can say that the sun will be not visible during the night time, and also wind energy depends on the availability of wind. So at that time there is a less usage of these energies. Power quality issues. Poor power quality can have major adverse effects on the power grid as well as industrial processes. Resource location. Renewable energy resources depend on weather, climate, and geographical location. So, along with the production of the energy, we have to know about the location of the resources, information barrier, and cost issues. So, the challenges are classified into two types. They are technical and commercial. So conclusion, renewable technologies are considered as clean sources of energy, and optimal use of these resources decreases environmental impacts, reduces minimum secondary waste, and are sustainable based on the current and future economic and social needs. Thank you.
Okay, good. Madam, we will take next presentation.
Okay, sir. Thank you, Sahana. Now I call Samruddhi Menashi from SSMS College, Atani.
Yes, ma'am.
Okay, you can start now.
I'm not able to share the screen. Okay.
Okay, wait 1 minute.
I got it.
Okay, you can start.
Just a moment, ma'am.
You share your screen.
Yeah, I've done that, sir.
Just check it once. Samruddhi,
Yes, sir.
now you can share your screen.
Okay, sir. So I'm not able to get it, actually.
A green color share screen option is there
I got that.
at the bottom of the screen.
I got that, but I'm not able to. My account, like, it is showing that it's unsupported document.
You are presenting through mobile or laptop.
Mobile.
Samruddhi, you can present afterwards.
Okay, okay, sir.
Till then, check your file.
Okay, fine.
Next participant is Shantava Sanganawar from Tunga School and
Yes, ma'am.
Basic and Applied Science College, Jamkandi.
Yes, ma'am. Can I share the screen?
Yes,
Okay,
share.
Hello,
Start now.
good afternoon to everyone. Happy National Energy Conservation Day to all. Myself, Shantava Sankanava, student of the BSc 5th SEM in Tunga Basic and Applied Sciences, Jamkandi. Welcome to all my seminar presentation, which is based on the hydrogen fuel cells, benefits and challenges. What is a hydrogen fuel cell? Hydrogen fuel cell is a electrochemical cell. Hydrogen fuel cell generates electricity reduction and oxidation reaction within the cell. They use three main components such as fuel, oxidant, and another one is a electrolyte. Hydrogen fuel cells operates like a normal batteries, although they are required to external fuel. Hydrogen fuel cells are the thermodynamically open system which can exchange the heat and energy also. Hydrogen fuel cells use hydrogen fuel and oxygen as an oxidant and proton exchange membrane as an electrolyte and emit only water as a waste. Next, move on to the next. How do they work? The hydrogen fuel cell battery, such as two compartments. One is the anodic compartment, another one is the cathodic compartment. Anodic compartment and cathodic compartment semi-permeable membrane such as made up of a polyelectrolyte membrane. It allows the only positively charged ions to pass through the cathodic side, and negatively charged electrons must travel the external circuit and to move the cathodic side and the reaction of cathode reaction. Next, working of the hydrogen fuel cell. Fuel of hydrogen is first transported to an anode of the cell and fuel undergoes the anode reaction. Anode reaction splits the fuel into a H plus proton and electron using the and protons pass through the electrolyte and cathode. Electrons cannot pass through the electrolyte and must travel through the external circuit, which creates the usable electric current. Protons and electrons reach a cathode and undergoes the cathode reaction. Behind the chemistry of technology, two types. One is oxidation, another one is a reduction. In the oxidation, at the anodic side takes place with the oxidation, and catalyst used to platinum powder used to split the hydrogen to proton and electron. Hydrogen fuel. Anode side half cell reaction takes place. 2H2 gives rise to 4H plus and 4 electrons. The cell potential of energy is 0 volt in the oxidation reaction. And reduction, at the cathode side cell reduction takes place. Second catalyst used to nickel. It is used to recombine the protons and electrons and oxygen atoms from water. Cathode half cell reaction takes place. 4H plus and O2 plus 4 electrons gives rise to 2H2O. Cell electrode potential is 0.68 volt. The electrochemistry E cell value of the energy fuel cells equal to the E cell cathode and half cell reaction minus E cell anode half cell reaction. For hydrogen fuel, two half cell reactions show above. Calculate the energy of one fuel cell. We needed to subtract the anode energy from the cathode energy. Hydrogen fuel cell energy is equal to 0.68 minus 0.00 volt, which is equals to 0.68 volt energy is released the fuel cell. The uses and hydrogen fuel cells are such as there are many different uses fuel cells being utilized right now. Some of these uses are power sources, vehicles such as cars, trucks and buses, and even boats and submarines. We use to hydrogen fuel cells. Power sources, spacecraft and remote weather stations and military technology. Batteries for electronics such as laptop and smartphones. Next, move on to the challenges or problems regarding the hydrogen fuel cell. Lack of hydrogen infrastructure and need a refueling stations. Lack of consumers distribution system. Cost hydrogen fuel cells. In the year 2009, Department of Energy estimated is $61 per kilowatt. Honda FCX Clarity cost about $500,000 to make. Carbon cost proceeding hydrogen. Problems with the HFC car. Short range is nearly equal to 260 miles and warm up time 5 minutes. And advantages. And the advantages require the hydrogen fuel cell. It is eco-friendly. Eco-friendly means environmentally free, and it is not emission of any oxidation of nitrogen and no emission of carbon dioxide. Thank you for such a giving opportunity. Thank you so much, sir.
Sanganna avaru. Can you hear me? Hello?
Hello, sir.
Yes, there is a question. So in the reaction, in the electrochemical reaction, what are the byproducts?
In anodic side, H plus ions are released, sir, and cathodic side, in anodic side reduction takes place. H2 and O2, sir.
Okay. Okay. Okay.
Thank you, Shantava.
Thank you.
On the pipeline, I request next participant, Samruddhi Meenashi from SSMS College Atni, to start their presentation.
Samruddhi, you can start now. Unmute your audio and start. Your screen is visible.
Yes, sir. Is it visible, sir?
Yes, it is visible.
Okay. Good afternoon, everybody. I'm Samruddhi Menshi from SSMS College of Pathani. Today I'm going to give a presentation on nuclear power plant. So the story starts in 1940s when two cities of Japan were bombarded with atomic bomb. Those are Nagasaki and Hiroshima. Then the craziest minds were running wild, and we knew that the future was atomic. So atomic age was just a few years far, but nuclear power was very, very complicated and very expensive. So what is nuclear energy? The nucleus of the radioactive atom splits to give free neutrons and energy. So the nuclear energy can be produced from nuclear reactions like nuclear fission, nuclear fusion. It can also be produced from nuclear decay. Right now, worldwide, there are two atoms which can be used for production of nuclear energy. Those are uranium and plutonium, which are highly, highly radioactive. So nuclear energy can be produced from nuclear reactions happening inside the nuclear reactor. So these nuclear reactions are of two types. First one is nuclear fission. So you can see there is a neutron and there is a heavy nucleus, which is also labeled as target nucleus. When the neutron comes and collides with the target nucleus, it releases three other neutrons with fission products. This also releases high amount of energy. So this energy is known as nuclear energy. This nuclear fission was discovered by German chemist Otto Hahn in 1938 with his assistant. In this reaction, uranium and plutonium are used. Now, nuclear fusion. In the screen, you can see deuterium, which is isotope of hydrogen, and also you can see tritium, which is also an isotope of hydrogen. The nucleus of both these elements combine together and they release helium and a neutron with a large amount of energy. Coming to next, how do nuclear power plant work? So maximum number of nuclear power plants were built in 1970s to 1985 after the Second World War. The most ideal type of nuclear power plant was light water reactor. The working principle is quite simple. It heats up the water and produces the steam, which again runs the turbine and gives off the energy. With using the artificial chain reaction, the water is heated up. So uranium-235, for example, uranium-235, or it can also be plutonium, is used under nuclear fission. So working of light water reactor. So light water reactor produces heat by controlled nuclear fission. If not controlled, it can be miserable. In nuclear reactors, in nuclear reactor core is placed where nuclear reaction takes place. A bundle of pencil thin nuclear fuel rods are inserted, which are about 12 feet long. The heat is produced by nuclear reaction, heat up the water to steam. Then the steam is passed through the turbine, which produces power. Then the steam turns back to water in the condenser. So core of the reactor. The core of reactor consists of three things. First is fuel rods, control rods, and moderator. Fuel rods are nothing but they are made up of radioactive element. So fuel rods are 12 feet long and they are inserted in the core of reactor. So these radioactive element, for example, if you take uranium-235 is inserted with uranium oxide. And now control rods. So control rods are present in the core of the reactor to control the nuclear reaction, whatever is happening. So basically control rods are made up of boron, and because boron is a good absorbent of neutron. Moderator. Now moderator which increases the speed of the reaction. In older times it was made up of graphite, but now it is now we usually use water as moderator. So here we can see a simple mechanism of light water reactor. Statistical analysis in 2020, 22 reactors were there in 8 nuclear power plants, and it gives off 3.11% of total power, and 63 gigawatt can be produced till 2032. Now we can go through pros and cons. So pros: carbon free, small land foot, high power output, reliable, all that. But there are huge cons also, consequences as well, because it's a non-renewable. It costs high cost, it's very expensive, and most important, it produces large amount of nuclear waste, and the malfunctions can be claustrophobic. Here we can see the contra side and the pro side. We can see the situation, how bad it is in the contra and how It can be good and as bad as well. So now coming to the conclusion, nuclear power plants are also capable of producing huge quantities of electricity, further reducing the need of additional coal or gas. So it is very, very good in terms of as a future fuel. Thank you everyone for giving me the opportunity.
Okay, good. Madam, we will take next presentation.
Thank you, Samruddhi. Now I call Shubham from Government First Grade College, Chukodi.
Ma'am, I want to share the screen.
Share now.
So is it visible?
Yes, it is visible. Start.
Okay. Good afternoon, sir. Myself Shubham Ramali from Government First Grade College, and my I'm doing my fifth sem from this college, and my main streams are physics, chemistry, and mathematics. Today's my topic is to talk about nuclear power plant. So now let's start from a little history. Wait. Okay. Let's start from a little history about the nuclear power plants. In 1934, physicist Enrico Fermi conducted experiments, and he saw that neutrons could split heavier atoms into lighter atoms. And after seeing this, he and his team conducted many experiments, and then they saw that there was self-sustaining nuclear chain reactions, which led to huge amount of energy production. Okay, from that. They conducted many experiments again, and on December 20, 1951, EBR-1, the first power plant to produce usable electricity, was established in United States, and India got its first nuclear atomic power station, that is Tarapur Atomic Power Station in Maharashtra. Okay. Now what is nuclear power plant? A nuclear power plant is a facility that converts atomic energy into a usable power. That is, atoms, when reacted in the nuclear reactors, they simply produce electricity. We just assume it first of all. What happens in a nuclear power plant? The answer is nuclear fission. During nuclear fission, a neutron collides with a uranium atom and splits it, releasing an amount of energy in the form of heat and radiation. Which helps us producing a amount of energy. In a simple nuclear fission, only a small amount of energy is produced. But to produce large amount of energy, the nuclear chain reaction takes place. That is, from a single neutron, which hit an only single uranium atom, it then bombards with many uranium atoms, and then a large amount of energy is produced. Uranium atom is one of the isotopes that fissions easily during fission. Uranium-235 atoms absorb loose neutrons that causes and becomes unstable and split into two light atoms called as fission products. The predominant radioactive fissions may be different for different isotopes. That is, iodine, cesium, strontium, xenon, and barium are some of the isotopes formed from uranium and plutonium, which are radioactive elements. This is how electricity is generated. Actually, when cold water is pumped into a nuclear reactor, they get heated up and steamed, which runs the turbines, and then so from the turbines the generators produce electricity and supply to every place. The advantages of nuclear power plant: consistent source of energy, generates low amount of pollution, high power output, reliable source of energy, space exploration. These are some of the advantages of nuclear power plant. Yes, we know the advantages of nuclear power plant, but how they have helped us till now? Nuclear energy has provided us 30% of world's low carbon electricity. Means with less amount of carbon releases, it has provided 30% of electricity to the entire world. Nuclear energy has provided 10% of world's electricity from 440 reactors. It has created many jobs, supported national security, and presently India has 22 nuclear power plants that is operating in 7 states with installed capacity of 6,780 megawatt electricity, and it is very, very high amount of electricity as compared to others. There are also some of the disadvantages of nuclear power plant. That is expensive to construct, generation of radioactive waste, restricted fuel supply of uranium or plutonium, which are very dangerous to extraction, and impact on the environment as many of the accidents Let us see some of the accident which have led us to tears, like Fukushima nuclear disaster in 2011, Chernobyl disaster in 1986, the 3 Mile Island accident in 1979, and the SL1 accident in 1961 are some of the accidents. Yes, we know the disadvantages and accidents and harmful effects, but to overcome this, the engineers and scientists have operated the next generation nuclear technologies. That is, they have created small modular reactors, molten salt reactors, micro reactors, and advanced reactors and fast reactors, which help us overcoming all the disadvantages and helping us for the next generation nuclear technologies, from which we can make our countries and our environment healthy and protected. Thank you.
Thank you, Shubham. Sir, any questions?
We'll go to next
Ah,
next presentation. Madam.
okay, sir. Now I request Sri Lakshmi Kulkarni from BK College, Chikodi.
So is the screen visible?
Yes, it is visible.
It is visible. Go ahead.
Good afternoon, everybody. My name is Sri Lakshmi Kulkarni. Presently, I'm studying in BSc 5th SEM from BK College, Chikodi. So I'll be presenting my PPT on solar energy. So as we all know, solar energy is nothing but the energy from the sun. Now, this energy has been manifested into a wide variety of devices called as solar devices, which purely run on solar power. So let us see those devices. So these are some solar devices which we can see on the screen. So these are the first one is solar water heater, and the second is solar air heating system. And even we got the solar powered calculator which run on solar energy. So it is literally like a boon to mankind. So first thing, and the question come to our mind is why there is a need of this solar energy, why we need to depend upon these. So the need for solar industry is, so the first point is world energy demand is growing fast. Why it is growing fast? It is due to population explosion and technology advancement. So it is therefore crucial to go for reliable, cost-effective, everlasting and renewable source for energy demanding rise in future. And also in the third point, solar industry is developing steadily all over the world because of high demand for energy. While major sources like fossil fuels are limited and other sources are expensive, then solar energy would be a best option for future energy demand since it's superior in terms of availability. So even we have got too many advancement in solar energy or solar technology. So let us witness those. So the latest advancement in solar technology is printable solar cells. Now this is a new term here. Printable solar cells are flexible, lightweight, and can be placed on a wide range of other materials. So these solar cells can even be printed in small sizes and can be incorporated into electronic accessories such as phones, tabs, and laptops. And actually, these printable solar cells, these are produced with inkjet printing on a sheet of paper, which allows solar cells to be much cheaper and be placed almost anywhere. Next is recently in June 2022, researchers at Princeton University, that is USA, they developed perovskite solar cell or perovskite solar cells, which can be manufactured at room temperature and requires less energy to produce than silicon-based solar cells. Now the question comes in our mind is, what is the difference between these perovskite solar cell and a normal solar cell? Normal solar cell are usually silicon based and these are very expensive. Why these are expensive? Because it needs to be produced from the silicon, which has to be extracted from the earth and processed before it can be used. But this perovskite solar cell, these are based on man-made material that can be produced at lower cost. And actually the chemical composition, mainly it is made up of calcium titanate. And also this year, the world saw the first ever production ready solar powered car, where solar panels have been added to recharge the car's battery while it drives. Now, what is the difference between these solar powered cars and normal cars? First of all, it has great effect on environment. That is, it is eco-friendly. They have zero emission level as they don't utilize non-renewable resources. And the most important thing is improved ozone layer condition due to reduced greenhouse effect. And also in these solar powered cars, they do not produce much noise. So they reduce noise pollution. And next, the future of solar energy, if we see, it is really very bright, because India has a great potential in tapping solar energy, as India is a tropical country. So India has got a lot of sunshine shining over, because it is a tropical country. We can utilize this solar energy to its highest potential. Also, in different parts of India, big power plants are being established. So this will drastically reduce the dependence on household in rural areas on dunkings, firewood. So this will help in ensuring that there is sufficient supply of manure for agriculture purposes, as well as to conserve the environment. So these solar cookers or the solar technology, it has even reached every nook corner of the world in the villages also, so that they won't depend upon those dunkings or firewood. And then last is, in the coming years, technology improvements will ensure that solar become even more cheaper. So by 2030, solar will have become the most important source of energy for electricity production in a larger part of the world. Thank you.
Thank you, Shri Lakshmi. So, any question?
Yeah, it is solar cells,
Yes, sir.
Can be used wherever. This can be like portable solar cells, right? Because as you said, in the patch-based solar cells, right?
Yes, sir.
We can use them like wherever we want.
Actually, those silicon-based solar cells, I think it is restricted to some places, but recently they have developed a new kind of solar cell which are not silicon-based, that is perovskite solar cell. They are telling that those can be used wherever, sir.
But why cannot we do it, no? Embedded in the polymers. Embedding silicon material in the polymers, or embedding these new material used for solar cells in polymers.
Yes, so that can be done, but the source of light should be available, sir, for that.
True, that is true. What is the speciality of these the new material based solar cells, that is patched solar cells? If you compare with this silicon, what is the speciality or what is the advantage?
The main advantage is, sir, those cells are from, if we compare to the conventional solar cells, they can react to various different wavelengths of light, sir. So which lets them to convert more of sunlight that reaches them into electricity. And they are also cost effective, sir, because it doesn't need much processing that we need to extract the silicon and all. So they are based on solution. They are prepared by a method called as solution processing.
Okay. In that way, these are good.
Yes, actually, they are now they are not commercially viable in India. They are actually exported in foreign countries, sir. But according to studies, they are telling that they can soon come to India also.
Okay. Thank you.
Thank you.
Thank you, Shri Lakshmi. Now I request next participant, Surbhi Nadi, SS Arts College, Sankeshwar.
Hello, madam. Please allow SSR's college to share the screen. Hello.
Yes, sir.
Hello.
Sir, please share SSR's college screen.
Yes, sir. You are co-host now. You can share. Yes, sir. It is visible now. Surubi, you can start now.
I am audible.
Yes, you are audible.
Hello. Hello.
Yes, you can start now.
Okay, sir. Good afternoon, everyone. Today, let us. Okay, sir. Okay. Good afternoon to everyone. Today, so let us discuss about hydrogen fuel cell as a future fuel. So, whenever think about a future cell, that is hydrogen.
So now I request next participant, Suvan Kadkol from KLE Society's RLS Institute, Belgavi.
Am I audible?
Yes, Suvan, you are audible.
Yeah.
Start.
Mr. Sexer, I'll just start. So shall I start now?
Yes, start.
Yeah. As a Prime Minister Narendra Modi just recently came up with this idea of Atmanirbhar Bharat. So what actually it means to become self-reliant. So how, in what terms he meant that? Like, as we know, India is an oil importer nation. We depend on foreign nations for the import of our oil. So as we know from this Ukraine-Russia conflict, how Russia can influence and use its oil exporter power to dominate the other nations and restrict the sanctions on itself and impose its and make whatever things it wants. So to become self-reliant in terms of energy is a need. So what we have? We have their battery-based electric vehicles and fuel cell-based electric vehicles. So what is the difference between these two? So first of all, let's see from my topic, the hydrogen, the fuel of the future. This is a part of FCEVs, which is a fuel cell electric vehicle. So,
Suvan,
yes, sir.
your screen is not presenting. It
Hello?
means your slide is not moving. You are still in the first slide only.
Yeah, now it is, sir. Now, sir.
Yes, now it is moving.
Yeah, sir.
Start from the beginning.
So again, I need to start.
You can continue. No problem.
Hello.
You can continue.
Go ahead.
Yeah. Okay, sir. So why hydrogen as a fuel? So hydrogen is renewable and readily available. It has we can say from the base of its production, it is clean as comparatively the fossil fuels, and it is more powerful and high efficient also. And charging time is also less as comparative to the battery-based series, and it can be used for a longer time as the battery EVs are need to be replaced as battery after certain usage period. And way to hydrogen. So how we can use hydrogen as a fuel? So first we need to extract it. The problem over here is the investment required. The investment in this technology is currently very less, and the cost of the raw materials, as the investment is less, so it's also expensive. and the regulatory issues. Like if the hydrogen is produced in Rajasthan and is need to be transferred to Bihar, so the states coming in between and the producer and the consumer state, the regulation need to be made clear, and the infrastructure all is required for that. The same. Hydrogen is highly flammable, and it can also cause some dangerous effects if not handled carefully. So, as I said, hydrogen can be produced using the source. Hydrogen can be produced using coal, methane, and renewable energy. Based on the source of the hydrogen production, the colors of the hydrogen are as shown on the screen. So yeah, now let's compare to my topic, the battery EVs versus the fuel cell electric vehicles. That is, as the best example we can see is for battery cell electric vehicles is Tesla, and for this hydrogen fuel cell is Toyota. So efficiency. The efficiency of hydrogen is more as comparatively to the battery-based electric vehicles, as you can see in the graph over here. So it's easy for, it's completely, yeah, it is as equal as the internal combustion engine over here. And next comes the energy output of this hydrogen fuel cell vehicle. As you can see on the screen, that hydrogen-based electric vehicles produce around 40,000 watt-hours per kg, whereas the lithium ion battery based you give an output of 250 watt per kg. So as you can see over here, is easily we can say hydrogen fuel based vehicles are more efficient and energetic than compared to battery cell vehicles. Refueling and the charging time. As we know, I'm one of the battery vehicle users. So I own a Ather. So as I can see on my daily basis, like I spend around 4 to 5 hours of charging that vehicle from 0 to 100. But in case of this FCEVs, we can see it takes a mere 5 minutes to charge it. So why don't we see this for fuel cell electric vehicles everywhere? First of all, the production of hydrogen is where it's concerned. So hydrogen is not greenly produced. So we have some carbon footprint in this hydrogen. So the process is inefficient. The amount of energy utilized to produce hydrogen is not is what we're getting back. And hydrogen vehicles are too expensive, as it's actually the process is too expensive. And the status, the fourth point, as I have mentioned over here, a status quo is maintained. A status quo I'm trying to state over here is the oil companies and these alternative fuel vehicles, they are maintaining a status quo so that both can survive on the same market. And battery technology need to be improved. So as the Elon Musk, the owner of Tesla, has stated, this fuel cell electric vehicles as fooled cars, not fuel cars. Yeah, in conclusion, I just want to conclude that this technology is just need to be limited to the logistical suppliers, because these guys can buy the hydrogen and have sorry. I just want to conclude that the hydrogen-based fuel vehicles are need to be just limited to the logistical department, because the cost, first of all, they are too expensive, and the companies can't make this. And basically, we are taking on battery-based electric vehicles. A driver can just drive up to 250 miles, 250 kilometers, but the logistical supply like trucks and all, the trucks they need to travel around 2,000 to thousands of kilometers together. So as I want to say is the technology is good, but not for the normal usage of cars and all, because the maintenance of these vehicles is too expensive. Actually, I just want to conclude that this technology is a boon or bane is just left to us, the way we take it. Thank you.
Okay, very good. Good presentation. Thank you.
Thank you, sir. Sir, any questions?
So we'll go to next presentation. No questions, madam.
Okay, sir. So now I request Vaishnavi Nayak from SSMS Athani.
Hello everyone. So shall I share the screen?
Yes, you share it.
Yes. So actually, I'm not able to share the screen, sir.
Maybe you try with one more mobile, no? Meanwhile, we'll take one more presentation.
Yes,
So you
sir.
try
Sure,
with
sir.
another mobile. Okay.
Sure, sir. Sure, sir.
Madam, we'll take one more next presentation. Meanwhile, she can do something.
Okay, sir. So now I request Vijeta from KRCS College.
Vijeta, share your screen.
Sir, I am not able to share it.
You are co-host now. You can share.
No, sir. I am not getting an option.
There is a green, there is a green button. There is a green button called share. Just click on that and you will get the
Only the host
options
can
to
share
share.
it.
Now share.
No, sir. I am getting an option that only the host can share it.
Vijeta,
Yes, sir.
share your screen.
Sir, I'm not getting an option. It's showing that only the host can share it.
Now you are co-host, no? 1 second. Vijeta, share your screen now.
Sir, I'm not getting an option how to share it. It's still showing me that host only can share it.
Okay, just wait for a few minutes. Or you will SS Sankeshwar.
Is there Surabhi Nadig? Are you ready?
Yeah, I am ready.
Hello. Surabhi, are you ready?
Yes, I am ready.
Okay, you can continue.
Okay, so we start now.
Hello.
Yes, you can start now. It is visible and audible.
Okay. Okay, sir. Okay, sir. So good afternoon, everyone. Today, let us discuss something about the hydrogen fuel, about the green hydrogen. Because the green hydrogen, it is the atmosphere, reduces the atmospheric content, that is CO2 and many things. So let us next. So where we can use hydrogen. So we can use hydrogen storage in gas grids and in use in transport and synthetic of fuels and use in industry. So there are so many types of energies where we can use hydrogen. So now, how we can store the hydrogen? It is not possible to store the hydrogen at particular temperature and also pressure. So how we can store? So there are 5 principal methods of hydrogen. So first one, compressed gas storage, where we can compress the hydrogen and we can store the hydrogen to use it as the energy. So in liquid storage, liquid storage means we should store it as a liquid. So how we get a temperature and the hydrogen is heating value of hydrogen is at about minus 273 degrees Celsius, where minus 258 degrees Celsius, where we can store it as a liquid. So next, it needs a plant that where we can store as a liquid. So what is that plant? So it needs a primary refrigeration, that is nitrogen plant. So in next line pack system. So in line pack system where we are using a fuel nowadays natural gas. So we should care them, and we should also that in also hydrogen we should care by minute and hour by hour. So next, underground storage. It is a mainly major type of storage where we can store the hydrogen, that is underground storage. So storage as a metal hydrides. How I can use that hydrogen as a fuel? That is storage of storage as a metal hydrides, where we can store the hydrides in the metals by reacting the hydrogen to the metal. So next, hydrogen transportation. So of course we are compressed the gases hydrogen. So how we can transport them? So hydrogen fuel can be transported through pipelines and liquid hydrogen transportation and metal hydride transportation. So in the pipeline system, the pipeline is directly proportional to the square root of the density of the gas. So density of the gas here, the hydrogen has the lowest density. So we can so that it is reduced to the 1/9 of the natural gas as compared to the hydrogen. So here the density of the gas is also low, and it should have the heating value up to 12.1 mg per megajoules per cubic meter. So next, in the liquid hydrogen transportation, where it needs the pressure and also it has the volume, and where we can transport the liquid hydrogen. So in the metal hydride transportation, so it also includes that the already we know that we are reacting with the metal like iron or something metals. So so that hydrogen can be extracted and we easily transport them. So it is sufficient, or it is good that metal hydride transportation is a better, because it will not cause or it will not cost more. So next, what is the utilization of hydrogen and what is the environmental prospects or effects? What is the economy of a hydrogen fuel? So where is the hydrogen transportation and also hydrogen extraction? So utilization of hydrogen, where we can use that. So first of all, we should know that hydrogen is already we are using as energy, but the main topic or the main intention is we should make it as a fuel, not as an energy, because I had energy is also is already we are using, and we should use them as a fuel. So what utilization of hydrogen is in the energy system, that is cars and cars transportation like railways. So there we can use it as energy. So environmental prospects or effects. So so one point I should notice that, so each year there is across 830 million metric tons each year there is a carbon dioxide is releasing. So we should reduce them. We should use the hydrogen, because it will reduce the environmental carbon dioxide, such as so next one, economy of a hydrogen fuel. So the cost of economy and also environment perspective of a hydrogen fuel is a major one. And next, hydrogen as an alternative fuel for a motor vehicles. So here, what happens? The minimum ignition value of natural gas will be high. So we already compressed the hydrogen to as a fuel. So we should compress it for the at a low temperature. So it will not ignite or it will not the ignition value will be not sufficient for the hydrogen fuel. So it should be up to 585 degrees Celsius. So you should overcome about this ignition value, and also safety and management. How we can use safe and the management are be done. So safety and management can be done by producing or at underground storage. So hydrogen technology development in India. So hydrogen production is done by hydrolysis or by proteolysis, and also by using bacteria, that is the blue green algae. So here already we know the Minister Road Transportation, that is Nitin Gadkari, has already stated that we up to 2030 we are first inventors of hydrogen fuel. So let us all be participating in that hydrogen fuel as a future fuel. Thank you.
Surabhi,
Sir.
so according to you, the hydrogen storage is good when you make it some other form, right? The hydrogen
Yes, sir.
gas
Yes, sir.
instead of making. So in terms of hydrides, you mean
Okay, sir.
metal
Yes, sir.
hydrides or something like that, right?
Yes, sir.
Okay, this is really good topic. But what I ask you is, the moment you store the hydrogen gas as
Yes, sir.
some other form,
Yes, sir.
so transportation anyway it is good. That
Yes,
can
sir.
be done by using transportation. But what about when you make it as a fuel, this metal hydrides and all? Is it recyclable? This fuel hydrides and all metal hydrides.
Sir, we already know that it is compressed at a low temperature. So where
Anyway,
it can.
that is okay. But the moment you make the compound, the hydrogen gas into metal hydrides,
Yes, sir.
so
Sir,
can it be
here what happens?
reusable?
Yes, sir. Sir, what happens in metal hydrides? The hydrogen will be exhausted. So when we
Okay.
heat them, and the metal what is left, that can be reused, sir.
Okay, it means that you need to unload the metals at the hydrogen gas stations and again
Yes, sir.
reload the metal hydrides.
Yes, sir. We can use that
Okay,
metal, sir.
Okay, good. Okay, thank you. We'll take next presentation, madam.
Thank you, sir. Thank you, sir.
Thank you, Vijeta. Now I call Vaishnavi Naik from SSMS College, Athni.
Hi, sir.
Hi.
Can I share the screen, sir?
Yes, you share.
Is my screen is visible?
Yes, it is visible.
So, okay. Good afternoon,
It is visible.
everybody.
Start now.
Okay, yes, sir. Good afternoon, everybody. This is Vaishnavi Naik from SSMS College, Athani. So today I want to give a presentation on the hydrogen fuel as a future fuel. So first of all, what is a fuel cell? In simple words, we can say it is an electrochemical device which converts the chemical energy into electrical energy. So as we go for the history of the cell, it is first demonstrated by the scientist Sir William Robert Group in 1839, and it is practically demonstrated by Francis Tree Bacon and J.C. Frost of the Cambridge University. And as per the parts of the fuel cell, there are 4 parts: anode, cathode, and catalyst, electrolyte, and And anode is the negative post part of the fuel cell, which conducts the electrons that are freed from the hydrogen molecules so that they can be used in the external circuit. And cathode, as per the cathode is a positive part of the fuel cell, and it channels the attached into it to distribute the oxygen to the surface of the catalyst. And catalyst is the chemical substances which increases the rate of reaction. And electrolyte is a substance that conducts the charged ions from the electrode to other in the fuel cell. Working of the fuel cell, as we can see here, there is a redox reaction anode side. What happens, the anode side, the oxidation takes place. The hydrogen atom splits into protons and electrons, and in the reduction and in the cathode side, the protons and electrons which are produced here combines with the oxygen to produce water, and the net reaction is as presented, that it gives the water. The hydrogen and oxygen combine to give the water, and the byproduct in the hydrogen fuel cell is water. And these are the advantages of the hydrogen fuel, which has the high energy yield, and it is most abundant element, and it can produce from many primary energy sources, and it is the most versatile fuel. As it also has some disadvantages, it is a low density, and it needs a large storage areas, and not found free in nature, and currently it is expensive. And these are some milestones.
Go ahead. Go ahead.
These are the milestones in the hydrogen fuel cells. The India's first hydrogen fuel cell car undergoes successful trials by CSIR, and the Toyota Mirai has been also launched a pilot project for India's first hydrogen fuel vehicle. And the Indian government is also pushing the state-run firms to start using as hydrogen as a fuel. And as we can see the difference between the lithium ion battery, what we are using in our day-to-day life, and as versus the hydrogen fuel cell. What the lithium ion does is just the lithium ion creates the electrical current by moving between the negative part, that is anode, and the positive part. It creates the electric energy by just moving from negative to positive part, while the hydrogen fuel creates the electrical energy by combining the oxygen and hydrogen. And so these are the sources which I have got the information. So thank you.
Thank you, Vaishnavi.
Thank you, sir.
Next participant is Vijeta Angarki.
Yes, sir. Yes, sir. Yes.
Vijeta, share your screen.
Sir, in the share option, I'm not getting the PPT.
Hello.
Sir, I'm not getting an option. Ha, sir.
You are co-host now. You can share your screen. Are you presenting through mobile or laptop?
Mobile, sir.
So at the bottom of the screen, there is you have option green color share screen.
No, sir, there is no option as only share I'm getting.
Then share, no?
Ha, sir, in that I'm getting like Microsoft OneDrive, Google Drive, and Box, and like that I'm getting, sir.
Go to document and open it. Go to document and open
Sir,
where is your,
am
now I
I?
can see it.
Huh.
Yes, it is sharing.
Yes,
Yes.
yes, of course. Now I can see
Okay,
it.
sir. Okay. Good afternoon, everyone. Uh,
Right.
just a second. National level webinar on the occasion of National Energy Conservation Day. I am Vijeta M. Hangarki from KRCS College of Education, Bailhangal, and I am perceiving the B.Ed second year. National Energy Conservation Day, it is celebrated on 14th December. Energy saved is energy earned. Let's work towards a sustainable world by embracing the new renewable energy. Theme is the renewable energy resources, opportunities and challenges. What is renewable resources? A resources that can be used repeatedly and does not run out because it is unnaturally replaced, such as a solar, wind, hydro, geothermal and biomasses. Let us see the types of renewable energy resources. They are hydro energy, biomass, geothermal energy, tidal energy, solar energy and wind energies. Next comes my topic, that is hydrogen fuel as a future fuel. I have selected this topic because it is the most trending topic, as a hydrogen fuel is the new one. Making of the hydrogen. Hydrogen does not exist alone in the nature. It combines with other elements to form well-known compounds such as water, natural gases, and the petroleum. Once separated, hydrogen is colorless, odorless, and highly combustible diatomic gases with a molecular formula H2. The overwhelming majority of the hydrogen is currently produced from the fossil fuels, including the natural gases and the coals, and also the steam methane reforming, that is SMR. The hydrogen fuel can be produced with the cost effectiveness through the electrolysis by splitting the water into its constituent hydrogen and oxygen atoms. This generates the two useful gases, and when powered by the green energy makes the hydrogen production and a carbon neutral act. Let's see the hydrogen economy. The hydrogen economy refers to the idea of transforming our existing hydrocarbon based infrastructures from the static power generation to the full range of the transportation applications to run on hydrogen in order to cut carbon and carbon dioxide emissions. This transformation can occur wherever the hydrocarbons are used as a fuel. But there is a particular interest in the potential transport applications where the fuel cell electric vehicles, that are FCEVs, are seen particularly viable alternate to the conventional hydrocarbon powered vehicles. In the current hydrocarbon economy, the heating is fueled primarily by the natural gas and transportations by the petroleum. Burning of the hydrogen fuels emits the carbon dioxide and the other pollutants. The demand for the energy is increasing. Hydrogen carbon and can be environmentally cleaner source of the energy to end the users without release of the pollutants such as the particulates of carbon dioxide. Let us see the hydrogen fuel cell. The hydrogen fuel cells work as a batteries. It can convert the chemical energy in the fuel to the electrical energy. It is composed by the two plates separated by the electrolyte membrane. One plate is anode and the other is cathode. Here the H2 is passed through the anode one and the O2 is passed through the cathode one. H2 consists of the protons and the electrons, and the positive particles of the H2 can pass through the membrane. However, the negative particles change their path and generate their electrons to the electric current heat, and reaction is towards the cathode, and we get the end the byproduct as a water, that is H2O. Next comes the national hydrogen energy emissions. It aims to reduce the petroleum use, greenhouse gas emissions, air pollutions, contribute to more diverse and efficient energy infrastructures. Hydrogen consists of the hydrogen can be formed by the hydrogen fuel cells. There is no emissions, no expense, and the byproducts are the heat and water. Next comes opportunities. Hydrogen can be used to the power of a number of the different types of transportations. It can be stored and transported at a high energy density in the liquid or gaseous forms, and it can be used as a fuel for the power or transport in industry, and as can be stored as a feedstock. It can be used just like the battery electric vehicles. Hydrogen fuel cell electric vehicles, FCEVs, including the passenger cars and buses, are powered by the electricity and so produced no CO2 or other harmful emissions. Only the water vapor can be seen. Hydrogen powered cars are also being having the advantages of senses and take few minutes to add. We can use a hydrogen fuel for the heating purpose. There are a number of the new green home heating methods in research at the moment, including the high voltage and electro boilers and hybrid heat pumps. The CC's reports of the is especially optimistic that hydrogen could function well in the conjunction of the later solutions to provide the cheap, reliable, and low carbon alternatives. The hydrogen fuel can be also used in the form of the transport, being used environmentally as a friendly gas, which can be used in the reaction of the hydrogen oxygen to power the motor. Next is the hydrogen fuel cells can be used as like as a transportation material handling and also for the industrial heat generation is one of the biggest risks, so as to low carbon hydrogen solutions source and work in the tandem of the available resources. Challenges: hydrogen extractions, investment required, cost of raw materials, regulatory issues, highly flammable. These are the challenges of the hydrogen fuel cell. Conclusion: globally, the cost of hydrogen is already coming down, partly in line the following renewable energy. The citizens must be encouraged to use the hydrogen fuel vehicles and must be given information by the government. Ultimately, creating a global market for the hydrogen will need to cross the national and the region boundaries as we look towards the decarbonized futures. Thank you. Thank you, one and all.
Thank you, Vijeta. Sir, any question?
No questions, madam. We'll go to next presentation.
So now I request Vimal Modalgi from KLE Society's Nipani College.
Yes, ma'am.
Okay, you can start now.
Ma'am, please allow me to share the screen. Ma'am, my screen is visible.
No, it is not visible. You can share your
Is it
screen.
visible now? Is it visible now?
Go to screen share.
Okay, sir. So just wait a minute.
Vimal, go to screen share.
Hi, yes, sir.
Then go to document.
So just wait a minute, I'm getting it. So it is not coming with.
Anurupa, ready? Are you ready?
Yes, sir. Yes, sir. I'm ready.
Okay. 1 second. Anurupa, you can start now.
Yes, sir. Yes, sir.
Anurupa, share your screen.
Yes, sir. I'm sharing. Is it sharing?
Yes, it is sharing.
Yes, sir. I'll start my presentation.
Wait.
Good evening, one and all.
Wait.
Yes, sir.
Open your PPT. Yes.
I have
Start now.
opened it, sir.
Yes, start now.
Yes, sir. Good evening, one and all. Myself, Anirudh Parali. I'm from PC Job in Science College, Hubballi. I'm studying in 5th sem. So now the topic which I choose is it's totally different from what others have explained. That is, it is waste to wealth from sugarcane. So we know that India is the second largest sugarcane production next to Brazil. In sugar season in 2021-2022, a record of more than 5,000 lakh metric tons of sugar was produced in the country, out of which 3,574 lakh metric ton sugar was crushed by sugar mills to produce around 394 lakh metric ton of sugar. Out of this, 35 lakh metric ton sugar is converted to ethanol production. And we know that in sugarcane industry, sugar is a main product, and there are several byproducts like sugar, molasses, bagasse, press mud. We have a more benefit by using molasses and bagasse. After crushing sugar cane, we get a sugarcane juice and a bagasse. By using bagasse, there are many, like bagasse is fibrous residue left over after sugarcane is crushed. There are many used advantages by this bagasse. We can make a fuel, power generation, biogas, biocompost, and etc. So what happens is by using this bagasse, we produce the electricity around 100%. 60% of electricity is used or utilized by the industry itself, and 40% of electricity is sold to the other places or other countries. Here comes a scenario that during 2021-2022, a revenue of about rupees 18,000 crore has been made by sugarcane mills or distilleries for the sale of electricity, and this solved the problem of the India's loss, which has been debted by the sugarcane industry. So we know that after bagasse, which is boiled around higher temperature, and it goes to a steam mill drives and steam turbo generator. Later, it is turned into steam and power. Next, this 60% is used by the industry itself, and 40% is used as a surplus electricity to grid. And the main concept of us is like what I'm explaining is blending of petrol. That is 20% of ethanol is blend with the 80% of petrol. We know that in India around in the year of 2002. In the year of 2002, India has been started ethanol blending petrol by 1%. And in 2020, in 2013 and 14, it has been blended with 1.5% of ethanol with remaining petrol. And in the year of 2021 and 2022, around 10% of ethanol is blended with 90% of petrol. And now India is planning, or it is decided to achieve around 20% of ethanol, which is blended with 80% of petrol. So by 8 years, we'll earn nearly rupees 40,000 crore. This massive production of sugarcane will enhance the country's richness or its economy. So the government has encouraging sugar mills to divert sugar to ethanol, and also to export surplus sugar, so that sugar mills may make payment of cane dues to farmers in time, and also mills may have better financial conditions to continue their operations. So molasses, which is based on alcohol production in India, we know that ethanol blending petrol
in order to increase agriculture and minimize pollution, the Ministry of Petroleum and Natural Gas, who is Hardeep Singh Puri, has announced that ethanol E20 fuel or E20 vehicle will be available in India ahead by schedule by December 2022 or January 2023. So we can use this ethanol blending petrol to our vehicles. But it is quite difficult currently because we have to modify the vehicles due to this reason. Let us see the advantages of ethanol fuel. It contributes to creation of employment to the country. We know that even many people are eligible to the work, but they are lacking due to their jobs. So ethanol fuel is cost effective compared to other biofuels, and it is ecologically effective, and it helps to reduce the global warming. It is easily accessible, and it minimizes the dependence of fossil fuels. It opens up untapped agricultural sector. Ethanol fuel is a source of hydrogen, and it is also an alternative to the fossil fuels. Disadvantages of this ethanol fuel is it is spike in food prices. You know that we can extract this ethanol by using sugarcane and some corn, wheat, maize, etc. So if we produce this in large amount, we'll be lacking about to generate other sources. So it is difficult to vaporize, and it is a as we know that sugarcane is a water deficit we yield. So it is an affinity for water, and the distillation process is not good for the environment, and it requires a large piece of land. And hence, most petroleum products are used in transportation. Hence, successful ethanol blending petrol can save around countries 30,000 crore. India has earlier set target of introducing E20 fuel by 2023, but it will be implemented around 2025 with 20% of ethanol and 80% of petrol, which is also enhances our Atmanirbhar Bharat project, which is concluded by our Prime Minister Narendra Modi. It also strengthens two pillars, which is economy and demand, which is sectored under the Atmanirbhar Bharat scheme. And ethanol, electricity, and biogas is a biofuel coming from sugarcane, which is also a less polluting fuel, which reduces the carbon emission from vehicle. Thank you.
Thank you, Anurupa. Sir, any questions?
Madam, no questions. You can take next one.
Okay, sir. Last but not least, I once again request Vimal Mudalgi from Jaya Bagawadi College, Nipani.
Please allow me to share the screen. Okay. Is my screen visible?
Yes, it is visible.
Yes. Good evening to everyone. My name is Vimal Rashekar Mudalgi of KLE GI Bagawadi Arts, Science and Commerce College, Nipani. Today I will be doing the seminar on renewable energy resources, opportunities and challenges. So here is the table of contents. So what is renewable energy? It is the energy that comes from replenishable natural resources like sunlight, wind, thermal energy, moving water, and organic materials. Renewable resources do not run out. They are cost effective and renew faster than they are consumed. So here are the types of energies like solar energy, wind energy, hydrogen, and biomass energy. Today I will be discussing on nuclear power plants. So the nuclear power plants, the idea of this nuclear power began in 1930s when Enrico Fermi first showed that neutrons could split atoms. Nuclear reactors are the modern day devices extensively used for power generation. Nuclear energy is the energy in the nucleus or the core of an atom, and it is released due to nuclear fission. Basically, nuclear fission occurs when neutron slams into a larger atom, forcing it into excite and split into smaller atoms. Element called uranium-235 and 238 are extensively used. So the its mechanism is very similar to that of furnace in a system generator. The is used to drive the turbines of electric generator system. It consists of three crucial components: fuel element, moderator, and control rods. So fuel elements, it comes usually in the form of thin rods of about 1 centimeter in diameter and contain fissionable nucleus like uranium-235 or 238. In large power reactors, thousands of fuel elements are placed close to each other. This region where fuel elements are placed are called as reactor core. They are usually immersed in water, which acts as moderator. So what is basically fusion? When thermal neutron bombards on uranium-235, the prompt neutrons are released fastly. So now moderator. The objective of moderator is to slow down the energy, these energy neutrons, which are produced during the nuclear fission process by the fuel elements. It moderates the speed of these high energy neutrons so that they can in turn be used for a chain reaction to trigger multiple fission reactions of uranium-235 nuclei. So commonly, heavy water is used as a moderator in nuclear reactors because of the deuterons present in them, which are capable of slowing down the high energy neutrons. And third one are control rods. The main function of control rod is to absorb any excess or spare neutron in the moderator in order to prevent any further fission reactions. Usually, one control rods are made of boron and cadmium, working of nuclear reactor. So it is enclosed basically of shield made up of thick concrete walls. It consists of reactor core, pump, and heat exchanger. The reactor core and pump are placed in contact with the water, which is usually heat exchanger in these reactors. Due to enormous amount of heat released during fission reaction, the surrounding water also gets heated up and changes to steam, which in turn used to turn the turbines. So huge heat and energy gets converted into electrical energy. Water is continuously flown in and out of the nuclear reactor using the pump. So finally, using a nuclear reactor successfully generates nuclear energy from fission reaction. As it is said, coin has two faces, so do the nuclear energy. It has the advantages and disadvantages. It is one of the most low carbon energy sources. It also has one of the smallest carbon footprints. It is reliable and cost effective, zero carbon emission, and large power production. And disadvantages are that it is expensive to build. Uranium is technically non-renewable. Risks of handling nuclear waste is big. As we are aware of Chernobyl nuclear incident happened in Soviet Union, and it also has high maintenance. Malfunctions can be catastrophic. So we can draw the conclusion that while renewable energy sources are expected to continue growing significantly, nuclear power must also play its important role. In addition, nuclear technologies do not merely provide energy, they are improving people's lives, which is very important. In many other ways, they are also supporting sustainable development. Further, nuclear power plants benefit humankind in one or the other way, but experience shows that careful planning of the objectives, roles, and responsibilities are disposing nuclear waste safely should be carried out in order to achieve success. So in conclusion, further innovation and technological development will enable even wider applications aimed at decarbonization of economies around the world and supporting sustainable development. So we should protect the earth. Thank you for giving me this opportunity to speak. Thank you.
Good.
So is there any
Thank you,
question?
Vimal Mudalgi.
Thank you,
No
ma'am.
questions, madam. No questions.
Okay. Now it's the end of all presentations. So now I request Dr. Nagappa Terda sir to share their opinions about this presentation section. Over to you, sir.
Thank you, madam. The outset, can you hear me?
Yes, sir.
Okay. At the outset, I congratulate the organizing committee and the principal for conducting national level webinar comprised of a technical session followed by various presentations. So it was really difficult for me to select top presentations among all the presentations, because all presentations were much more competitive and very good impact. So I congratulate all the participants for your active presentations, as well as beautiful presentations, of course, and your active participations as well. For the sake of formality, we need to select top presentations. So we have selected for the sake of formality, because you all made very nice presentations, and in fact I thought, like, we could have given all the numbers. So for the sake of formality, we have chosen some of them. So I congratulate again for the in advance the winners of the this top presentations. So once again, I congratulate all the participants, and once again, I would like to thank organizing committee and the principal for giving me this opportunity to chair this session. Thank you once again. Thank you, sir.
Thank you, sir.
Very good evening to all the participants and jury member Dr. Enel Terdar. On behalf of Department of Chemistry and on behalf of BK College, I would like to thank all the participants for taking trouble in making the presentations and their interest. And also I will thank Dr. Enel Terdar sir for his all patience in going through all these presentations. And also thank our students for taking all the trouble in conducting this national level webinar, Miss Rohini Sajjan and Lavanya. So it was a good discussion on this platform. So it's a big challenge before us to deal with the energy in this scenario of the 21st century, where people are getting more conscious about their wants and rights, and also on the other side the population is increasing. So today we have had a great start with the keynote speaker Dr. Rafiq Mullah. Here he thoroughly narrated all the entire scenario of the energy crisis across the world, brought all the opportunity what we have in addressing these things. So these deliberations and discussions will definitely lead to the better India and better environment across the world. So once again, wholeheartedly thank you all for making this webinar is successful. Thank you one and all. And the result of the presentations will be announced soon. Today itself.
Sir, meanwhile, participants can share their opinions, right? Right, sir?
It will be, yes, it will be really good to have opinion of any of the participants. Please, anybody share your opinion?
Hello, sir.
Please,
Sir,
Pradeep.
myself. Yes, sir. Myself, Pradeep, sir, from KLE's SCP Arts and Science Commerce College, Malimpur, sir. Sir, it was a good session with everyone across the other colleges, and even we had a session with Rafiq Mullah, sir. He has shared a lot of knowledge with us, sir, and we got to know much more things from the renewable source of energy, and everything was marvelous, sir. So only one thing was, I hope in future we can meet up in one college and make a presentation offline, sir, so that it would be much more effective than this online session, sir. So it was my opinion, sir. And thank you for organizing this program and giving such an opportunity to build up our own general knowledge and to develop our speaking skills and much more things, sir. Thank you very much.
Yeah, thank you very much, Pradeep, for your kind words. And yeah, definitely we'll try to have the offline such deliberations. Any other participant, if you wish, you can share your opinion.
Yes, sir. Good evening, sir.
Please.
Sir, I'm Anirupa Arali from PC Job in Science College. Hello.
Yes, Anirupa, please continue.
Yes, sir. Thank you so much for providing such a wonderful opportunity to us, sir, because we don't know what capacity we were having. By having such events or such organizations, we will be coming out of our fear, and we'll come out with some energy, enthusiastic way, sir. So thank you so much, sir. When my teacher has been told that there is a session like this, so I prepared myself own concepts, and even I took some guidance from my sir, and I participated today, sir. And as the first time I missed, like I was out of network issue, and later you have been provided me the second chance, sir. Thank you so much. It was totally unexpected to me.
Yeah. Yes, Sanrupa, thank you for your kind
Yes,
words.
sir. Thank you so much, sir. Yes, sir.
You prepared your own presentation. That's really nice thing. Please keep it
Yes,
up.
sir. I mean, my sir has been guided this topic, sir. It's totally new, which yet has been not approved.
Really innovative. You brought up new concept into the picture. We'll see.
Yes, sir.
Thank you.
Yes, sir. Thank you, sir.
Any other participants want to
Yes,
wish
sir.
to? Please,
Sir, I, Vimal Mudalgi of KLE GIB College.
please.
Thank you, sir, for organizing such an event. Just last Saturday, I came to know about this event as sir informed me, and I've prepared the PPT, and I've, more than that, have gained the knowledge about all these renewable energies. Thank you, sir, for organizing.
Yeah, indeed, it was very short notice for all of you to prepare for this presentations. So next time, definitely make well in advance. The announcements will be made. Thank you.
Thank you, sir.
Yes. If anybody, so with this, I will stop this session. Now it's over to Rohini.
I would like to express my gratitude to our beloved jury, Dr. Nagappa Deda sir, and all students, delegates of the webinar for their presence and contribution to make this webinar a great success. Thank you so much.
The participants can leave now.
Okay, sir.
Thank you, sir.
Thank you.